Good evening, I am Mr. Ish. Thank you for joining me for this video on matrix multiplying or matrix multiplication, a big part of matrix algebra and certainly something you can always see on any kind of exam or test, especially college level entrance examination. You know, these are matrices, they have certain orders, you have certain rows and columns, and the matrix order has to be determined before you can do matrix multiplication. If the order of the matrix is determined, from that you can see if the multiplication operation can be done. You determine the matrix order for each. As you see, you always look at rows times columns. This matrix here has one row and two columns, so it has an order of 1 and 2. This matrix right here has two rows and a single column, and you'd have 2 times 1. Matrices can be multiplied when you look at the orders for the matrices that are involved. If the inner two numbers are equal, then you can certainly do the application. You can certainly do the multiplication, and the result of that multiplication is equal to what you have in the outer aspect, and you would have a 1 by 1 matrix over here. When you look here at this lower one, you have 2 by 1, you have 2 rows and a single column. Here you have 1 row and 2 columns. When you're doing this type of examination, you see the inners are the same, so you can certainly do this, and the result will obviously be a matrix made of the outer two numbers, a 2 by 2. So you should be able to do that. Anytime you're looking at a row multiplying with a column, your computation is always involving a product plus and a product. You see how you'll have AC come over here, A will multiply with C, and then you'll have plus with the next component adding to it. So anytime you're seeing row multiply with a column, you'll always have a combination or a sequence of products, sum, and products, however many might be in that chain. When you have this type of style where you have column multiplying with the row, you'll have individual elements come into play, and only products will come into play, and there'll be no adding. Here you'll have AC come into the first element, here you'll have AD come in the next element, here you'll have a BC, and then here you'll have a BD. See, you're only having individual products, there's no summation going on. Keep that in mind as we look at the next two examples of this video. So our first test question is this: two matrices which are being multiplied. Always start by determination of the order of that matrix, rows times column. You have 2 rows and 2 columns. This other one is 2 rows and a single column. Next, compare for multiplication purposes these inner two numbers. If they're equal, it's good because you can then do the multiplication. Next, evaluate the outer two numbers. That will be the result of what your final matrix will look like. 2 rows with a single column, and you will have to then do the actual operation. You have rows being multiplied with the column, so remember, you will have a combination of products and sums. 2 times 5 is 10, plus 4 times 3 is 12, is 22. Next you'll do minus 1 times 5 is a minus 5, plus 0 times 3 is a 0. You just have a minus 5. So remember, again, when you're doing a row against a column, you always have a combination of multiplying, then plus, then multiplying, then plus, however as the sequence goes. And that's always the case like that. This row multiplied with this column, next then this row multiplied with that column, hence the two numbers. And this question is done. Now for the last question, we have this: these two matrices are multiplying with one another. Always start with the determination of the order. Order is the number of rows times the number of columns. You have 3 rows and you have a single column. Here you have 1 row and 3 columns, you have 1 by 3. Next you examine the inner numbers. Are they the same? Yes, they are. Then you examine the outer number, because that gives you the extent of what your matrix will be. Your final matrix will be the product of the 2 outer numbers, a 3 by 3 matrix. And now you got to actually do the work over here and determine this. 3 by 3 tells you there will be 9 elements. 1, 2, 3, 4, 5, 6, 7, 8, 9, 9 elements. Again, here what you're seeing are column being multiplied with rows, so you'll just have products come into play. 3 times 4, 12, 3 times 5, 15, 3 times 0, 0. Then let's go to this row. Minus 1 times 4, minus 4. Minus 1 times 5, minus 5. Minus 1 times 0 is a 0. And then this, minus 2 with 4 is a minus 8. Minus 2 with a 5 is a minus 10. And minus 2 with a 0 is a 0. And it's done. And this answer should be good. And we wrap this video with this last example. Thank you for watching. Stay tuned. Have a nice day.